Hey Mike, how's it going?
Good. How are you?
Hey, everything's great. I was just on the phone with Barrett. I know he's going to be joining us in a second. Thank you.
Okay. Sounds great. Thanks, Greg. So just let me know when you'd like me to go ahead and get started. I think we're probably still waiting on folks to join in.
Yeah, sounds great. Hey Mike, I don't see where Cara is on right now. Looks like we've got a lot of folks here. I guess we can give her a few more minutes.
Oh, hey,
Okay.
yeah, this is Patrick. I'm actually filling in for Kara. Yeah, normally we maybe wait about 5 minutes or so and then we kick things off.
That'd be great, Patrick. Thanks, bud.
Yep. Okay, great. It's just about five after, so I think we could go ahead and get started. I did just put everyone on mute, so Mike, when you are about to talk, you'll want to go ahead and unmute yourself there.
Sounds great.
Okay,
Thank you.
perfect. Perfect. So, yeah, I'll do a quick introduction, and then I'll hand it over to Mike. But so this is our second AWS User Groups of Florida virtual meetup. As we talked about in last month's, we're hoping to get these pretty much going every month. As always, we welcome any feedback from the community around topics you'd like to see covered, or if like in the case of Mike, you'd like to actually present on a topic that's near and dear to your heart, please definitely reach out. We have a number of different meetup pages out there on meetup.com for when we were physically doing these. And at the end of these events, we do post both the presentation and the video of the presentation out there for your reference. And if you're not already familiar with the app, you can essentially raise your hand and ask questions in the bottom right-hand corner. And with that said, I'll go ahead and hand over to you, Mike, to kick it off.
Awesome. Thank you very much, Patrick. Just a quick sound check. Can everybody hear me okay?
Yeah, I can hear you great.
And we see your screen.
Perfect. Thanks so much. So yeah, what we'll do is I'll go through a quick introduction here. Again, huge shout out and thank you to CloudHesive for having us today, as well as GuidePoint Security. I'll briefly introduce myself. On a follow-up slide, I'll turn it over to GuidePoint for just a moment, for just a minute, and then we'll dive into the actual content in the presentation. So again, my name is Mike Rago. I work for a company called CloudKnox, and today we'll be talking about cloud breach incident response and forensics, and kind of weave in research we've been doing around the cloud infrastructure cyber kill chain. This is a mashup of a lot of research we've done over a period of time, and includes things that we've talked about at DEF CON, at RSA, and other conferences in the past. And hope you guys enjoy it. I have 5 talks in 6 days here, so this has been a hot topic. So again, thanks for having me. Just a brief one-slider on CloudKnox. Then I'll turn it over to GuidePoint for just a moment, and then we'll dive into the agenda. For those of you who are not familiar with CloudKnox, we are a small startup focused on managing permissions. And how we do that is really looking at identity activity. So a systemic issue we see across every organization is really a huge delta or deviation between permissions in the cloud that have been assigned versus what's actually being used. And from that, we tend to find a lot of high risk, a lot of high risk permissions that we really bring out. And we have automation for helping clean up the environment, generate those AWS JSON policies for least privilege, and really prune back a lot of those unnecessary permissions and access to resources. And then we complement that with all of our outlier and anomaly detection when we see a huge uptick in usage of permissions or broad access to resources. With that, I'll turn it over to GuidePoint for just a moment, and then we'll dive into the agenda.
Great. Thanks, Mike. Yeah, this is Greg Barnett from GuidePoint Security. I'm based here out of Delray Beach, Florida, and really appreciate being on here. We have a very strong cloud security consultative practice. Murdoch's on here also. He's a member of our team, but we probably have about 15 folks that are have a very I would say, specific background in just cloud and multi-cloud security environments. One of the things we work with on CloudKnox is just a general risk assessment as to understanding what identities have access to what, right? One of the common things we've helped a lot of people with on-prem before, but now is, how do you do that in the cloud? So looking forward to Mike's presentation here. I've seen it many times, and it's great. And what Mike didn't mention also, he's also an author. So maybe he'll mention something about his book here later. So thank you guys again, and appreciate the time.
Awesome. Thanks, Greg. So in terms of the agenda then, one of the most common and frequently asked questions in the context of incident response and forensics is really, what am I looking for? In our engagement and working with a variety of customers, and we know that GuidePoint sees this as well, is still kind of a huge lack of processes, approaches, and really, technical walkthroughs in terms of, how do I go about, incident response and forensics? What things should I be looking at? How do I analyze the data? Where does it live? All of those things. And we'll bring that into the context of a lot of the recent cloud breaches. We've seen a maturity in terms of the TTPs, that being the tactics, techniques, and procedures that attackers are using, both from an outside-in perspective, but also from an insider threat as well. And that'll give us really good insights into the cyber kill chain, but applied to cloud infrastructure, those things related to compute that I'm sure many folks on the line here have a huge depth of experience across AWS. I do this same talk also normally for Azure and GCP as well, and really kind of cover that for other organizations or other meetups, conferences, things of that nature too. And then we'll walk through the cloud infrastructure cyber kill chain in a little bit more detail. We'll talk about some AWS specific forensics approaches and how-tos and kind of where to get started. And then wrap up by covering some additional resources that you may want to look into. And then we'll open it up for Q&A as well. So what am I looking for? Many of the things that we see systemically across every organization is that related to, in one case or many cases, really a huge uptick in activity, that being identity and account activity, both for human and non-human or service accounts as well. Many of the recent breaches have taught us that, hey, not only are you going to see activity, but you're going to see activity outside of the norm. In every organization we've worked with so far, there's a huge deviation in the quantity of permissions that people have versus what they're actually using. And with that huge delta allows you to baseline and say, Dave, the developer, normally does, 3 or 5 specific functions on a daily basis. And that's what I've seen over the last 90 days. But although Dave, the developer, by default, has over 8,000 permissions, most of which he's never used. So looking at a huge uptick in identity activity, especially a deviation from the norm, is huge in terms of identifying those anomalies or outlier activity. Also, there's a plethora of resources, right? You've got DynamoDB, you've got RDS, you've got Lambda, S3 buckets, EC2 instances, just a plethora of services sitting out there. Those too can be analyzed from a resource perspective to also understand what resources does Dave normally use. Maybe Dave has a much broader access to the entire infrastructure, maybe across multiple AWS accounts, but what does Dave normally use? Also, for folks that are fairly new to AWS and other cloud service providers as well, is that how you access the environment may be a little bit different from your traditional on-prem, meaning that, for example, within AWS, your accounts have usernames and passwords, and to complement that, hopefully some form of multi-factor authentication. But the other way, and the more common way, administrators and developers are using the environment is via the command line or via APIs. And for that, AWS, of course, provides for access keys. So identifying where those exist in the environment, how they're being used, and how developers and even other folks make mistakes in terms of how they might accidentally expose those also becomes very important in understanding access, identifying when nefarious activities are occurring, and how you can approach those problems. But this is more than just, penetrating the environment and getting access to it, especially if it's an insider threat. There are also signs that you can look for that are related to lateral movement, privilege escalation, as well as exfiltration. So we'll look at those too and the aspects of that and the permissions related to some of that. And every organization we work with also has inactive identities, roles, and resources. And this is just simply because these cloud environments are growing like a carbon life form. It's difficult to stay on top of all the permissions, all of the access, all of the resources that are being created and used out within your cloud environment. And so also identifying when you have these inactive identities, roles, and resources is also key in terms of identifying anomalous or nefarious behaviors. Hey, this account's been inactive for over 6 months, and suddenly it's doing all these activities, right? It makes common sense. We'll also talk about something that's fairly unique to AWS, and that, of course, is role chaining or cross-account access, in that you can have identities that live within a particular AWS account or subscription, but allow cross-account or SDS assume role type access to do things in other accounts. And that's more or less how AWS is designed, is to allow that activity. But of course, in the context of attackers, and their lateral movements, they want to exploit that and finding new ways in which they can hop from account to account, understand what permissions and policies exist tied to those specific roles, and how they can exploit that or even perform things like privilege escalation. And then we've got some of our traditional things too, right? Source, IP address, geo, and we'll also talk about security groups, which in my humble opinion is just a fancy name for an ACL or firewall role, but tied to your EC2 instances and other portions of your infrastructure. So for that, we like to first kind of outline the problem. And when you think about the primary cloud service providers, that being Google Cloud, also Azure, and of course AWS, there are thousands of permissions in each one of those respective cloud service providers. For AWS, I think it just encroached on 8,000, just kind of tipped over into I think about 8,006 or a little bit more permissions you get by default when you create an account. And of those permissions, which ones are kind of dangerous? I mean, even if you simply just look at delete and or create functions, both of which can be very damaging to the infrastructure in general within your AWS deployments, which of those are high risk? They're very embedded, in terms of all of those different permissions. Mapping those out can be quite difficult, but understanding what some of the key ones are provides you a good starting point in terms of understanding deviations and understanding when there are important elements or data points related to incident response and forensics. And as we mentioned, less than 1% on average of the permissions assigned to each and every identity, human and non-human, are actually used. So what we're really saying here is that those other 99% permissions could allow you to avoid risk, right? And that's sort of the underlying theme as we go through this in more detail. All right, so one line of script can definitely cost you, right? There's some very powerful commands, as we know, within AWS. Some of these can wipe out huge portions of your cloud infrastructure. And so at the end of the day, the thing that keeps people up at night are some of these super dangerous commands. And even in the right hands, but used by accident, could wipe out some, if not all, of your infrastructure. If we look at the maturity in terms of the kill chain analysis and map this to cloud infrastructure, when I think about the traditional, cyber kill chain, I'm an old guy, right? And I think back to my days working at the NASDAQ stock market circa 1993, 1994, right? And at that point in time, I was a Unix system administrator and an Oracle DBA. And I downloaded a tool called Satan, which was one of the first vulnerability scanners long before there were commercial scanners like Rapid7 or Qualys or other products, right, or Tenable. And at that time, I said, hey, this is going to allow us to find all of our risks and vulnerabilities across the Solaris environment. So I ran it full bore on the network in the middle of the day and all the trading system floor, servers, and took down the trading floor in the middle of the day. So obviously that wasn't a good thing, right? But it was an accident. And, some lessons were learned from that. One was I almost got fired. I got called into the CISO's office, although they didn't call them CISOs then, it was VP of Security. Got called into the VP of Security office, and he said, listen, Mike, I'm here to offer you one of two options. You're either fired or you can take a promotion. And I certainly couldn't go home to my wife and tell her I'd been fired. So I took the promotion and asked questions later. But effectively, he told me, listen, at this point in time, we don't really have a lot of, security people here, and nobody really understands the network all that well in terms of how to protect it. You already manage the firewalls, Mike. You do, manage DNS and bind. So a lot you already do here in terms of the infrastructure. Now it's your job to protect it. And basically, I marched out of his office and took that as my marching orders. So what does that have to do with cloud infrastructure kill chain? Well, it really maps back to understanding the risks that can come about from your infrastructure, in this case, cloud. For example, in the first evolution of what we've seen in the cloud has been largely focused around misconfigurations. What does my perimeter look like? And that was sort of where we started, with on-prem as well, right? Do you have a firewall? Is there a DMZ? How do you have NAT configured? Well, we've gone through that evolution in terms of security groups and protecting the perimeter in terms of the cloud infrastructure and identifying misconfigurations. These misconfigurations can stem from inappropriately configured security groups, allowing access via RDP or Secure Shell, or furthermore, allowing any IP in the world to connect, right? Some of this is designed, purposely for, providing, web applications and things that you want to provide in the cloud. So context is always important, but where we're going with all of this is, a lot of people have deployed products and buttoned up a lot of their, perimeter, a lot of their cloud infrastructure from an initial misconfiguration perspective. Not to say that problems aren't still occurring, but it's matured, people kind of understand it. But what we're seeing over the last few years, especially with virtually all of the recent cloud security breaches, is that although someone, was able to gain access to the environment, whether it be a vulnerability, a misconfiguration, an exposure of credentials, it was really what could they do with that access once they gained access to the cloud infrastructure as, a user. Or some form of identity, human or service account. And therein lies the real problem and the huge exposures that have actually occurred. And that really is based on a number of things. One is, how is your environment configured in terms of permissions? For example, do you have a kind of a baseline policies you assign to developers versus DBAs versus administrators versus other, groups of people? And are those permissions actually being used? Do you have a good understanding of all of those, high-risk permissions that might be included in that? Very, very difficult to do, right? And through that, attackers know that, and they're looking to either exploit that identity and use that to move laterally across the infrastructure, use that for privilege escalation, use that to further infiltrate the environment. Secondly, we talked earlier about cross-account access, and it seems most of the folks on this particular meetup have a strong depth of experience with AWS and understand the concept of cross-account access, which is very specific to AWS, and allowing role chaining, whereby, again, I can have an identity and access and a primary AWS account that I log into, but that STS assume role, that cross-account access, allows me access to other accounts to do other things as part of my job. Again, understanding how those roles and policies are configured, though, and the broad level of permissions assigned, maybe intentionally or more commonly by accident, are again things that attackers are looking to leverage for privilege escalation. We'll give you some cool examples of that. And then lateral movement. Again, cross-account access could be considered part of that lateral movement as well as part of privilege escalation. But again, those over-provisioned roles, which typically stem from role-based access control assumptions, are really leading to a lot of these breaches, because there's a ton of permissions sitting out there that is unnecessary risk, right? Not being used, should probably be decommissioned, set up least privileges, something of that nature. But at the end of the day, remember one thing: read-only access allows you to make a copy of the data. It allows you to download it. It allows you to exfiltrate it. So if we break these down a little bit more, we can use this as prescriptive advice in terms of how we want to go about doing our incident response. In other words, getting insights into, hey, what should I be looking for? So in taking a look at, what occurred in a very popular financial services breach that was kind of headline news, although this attack initially stemmed from a server-side request forgery related to a web application firewall, it was those next steps in the cyber kill chain that really led to this huge breach. For example, there were two primary things that occurred. One was this identity had really only been used with one S3 bucket and for a very isolated sole purpose. But when that identity had been provisioned and the permissions assigned, it was much more broad than that. And so the attacker discovered that this identity had far broader permissions and access than it was originally designed for, and leveraged that to further map out the rest of the environment, thus uncovering over 700 other S3 buckets, one of which contained very sensitive customer records. The other thing is, compared to what that identity normally would perform versus what was used during the attack, was that in a very short time window, a whole bunch of new permissions were used. They were assigned to that identity, but they had never been used. So there's a huge uptick in anomalous behavior, also over a very short time period, that also maps to, a huge anomaly in terms of the activity that was going on. And as many of us know, this led to, an exposure of over 100 million customer records. As we take a look at JSON policies and we kind of take a look at how these are configured, the most fundamental security concern and warning that folks provide is really, resource star, and how these by default are commonly configured, granting, almost admin level type access. And so, therein lies some of the problem as well, is that some of these default policies don't always necessarily out of the box, provide the best security for your environment. And we'll give you some examples that map back to this. But if we take a look at these permissions that we can render, from your AWS deployment, when you look at that, you're going to probably find most of your identities, whether they're local or SAML-based, are grossly over-permissioned. Users are using a very small portion of the permissions that have been assigned, but also identifying of those which ones are high risk. There, as we mentioned a few times already, right, is where, a lot of this lateral movement, privilege escalation is caused from, is from these over permissions that exist within your cloud infrastructure, in this case, AWS. Another incident that occurred is with actually a very huge and very popular security vendor. I won't mention them by name. In their instance, they actually had a multifaceted problem that occurred also. They had a developer who made a backup copy of the database, in this case, RDS. And that database snapshot was sitting out there with poor security hygiene. But in addition, the developer had been doing some coding, built some code, posted it to GitHub, and within that code contained the AWS access keys. Now, some of us probably know that AWS best practices, recommend that you rotate those every 90 days. And the reason for that is, hopefully, if this was to ever occur in your environment, by the time the attacker discovered the access keys, maybe by then they've been retired and rotated, and so they wouldn't be able to use them for access. So just a defense in depth kind of approach, right? Just one of many things you can do. But in this case, the developer posted them to GitHub. The attacker found that those access keys were sitting out there, used them to access the environment, found this backup of this RDS database, and within it were two really interesting things. One, user accounts and their password hashes. But in addition, and I consider this probably the bigger problem after working at VeriSign for 8 years, were all the certificates and their relevant private keys for every single firewall, for every single customer around the world. So if you think about that for a moment, the ability to leverage those certificates and potentially decrypt that traffic for any of their customers, right? Huge, huge problem. So these were exposed. This vendor had to go out and basically replace those certificates on every firewall for every customer around the world. And in terms of AWS access keys, as we've mentioned, best practices, always recommends that you rotate these every 90 days. Not the easiest thing to do, in terms of working with your developers to do that, but it is considered a best practice. But identifying if there are one or more AWS access keys tied to an identity is also important, as is, identifying any of those that are, sitting out there for a long time. We commonly find many of these that have been sitting out there for more than a year, if in fact multiple years, right? And for those, we found in most cases those people have already left the company, or that service account isn't even being used anymore. So if we start to break this down a little bit more and start to really map this out of what should I be looking for in the logs, how should I, think about this problem? Where do I start? Here are some examples of some highly risky, permissions, and these are things we frequently find. Most of these here on the screen are ones that are assigned by default as well. One of the ones that people are probably most familiar with does have to do with your security groups, both ingress and egress and those authorized permissions. Really with this, you have the ability to basically create or modify those security groups, those ACLs, those firewall rules that may be tied to an EC2 instance or something else. And really, this permission, as you might expect, can be very dangerous. Hey, Dave, the developer, can change these, right? And allow a different form of access, one that could be quite dangerous and expose things to the outside world. But a few others are quite interesting. For example, another default permission assigned to all accounts is this IAM create user. This effectively allows you to do exactly as it implies. Create another user account, create a dummy account that they can use for themselves. Now, if the person is nefarious or an insider threat, they can use this to create a dummy account for themselves, do nefarious things, and cover their tracks because they're not doing it under their own identity, but this dummy account they've actually created. Another one that's quite interesting is this update the assume role policy and STS assume role. And through this allows basically the granting of access for an IAM entity permission to basically assume a role. So you can basically update this leveraging this kind of permission, right? And this really can allow for lateral movement, as we know, as designed by STS Assume Role, to move from AWS subscription to subscription, or I should say, in this case, AWS account to account, and allow them to move laterally across the infrastructure. And then also in terms of privilege escalation is the IAM put user policy. Either by creating or updating, this inline policy, basically allows an insider or an attacker to specify a policy, gives them more broad permissions, almost basically to full admin, and can do things such as full S3 access. Again, most of these are the default permissions that are assigned. So if we bring this back to the kill chain before we dive deeper into this in more detail, you can think about this in kind of those old school methods, right? For many years I taught an ethical hacking class, and using those methods, maybe you read way back in your Hacking Exposed book that you found attending Foundstone classes way back, right? Those kinds of things. We would actually go out, teach those classes around the world. But this was always our basis, right? Which was, how are people doing recon, or footprinting the network? In the context of cloud, really start to take a look at, hey, are there public S3 buckets that are exposed? Are there access keys in public repositories like Pastebin or GitHub? And what are those misconfigurations in terms of my security groups? As you start to move through the cyber kill chain, though, and look at aspects of infiltration mapped to the cloud, we can think more about exploiting a lot of those IAM permissions, many of which we've talked about on the previous screen. Also, if I'm an attacker, I'm going to look for those inactive and dormant accounts, right? People aren't watching them. They've been sitting out there forever. Most of the time, people aren't looking for an account that suddenly wakes up. And in terms of things such as API or command line interface, access, how are people accessing the environment? One of the things I cover in a presentation that I talk about Azure is the fact that within the logs from the command line, a lot of the login information and other things are stored clear text in hidden files like .xyz, whatever file, right? And you can find some really interesting things in those that allow for privilege escalation. The attacker got access to the environment, then combed through those files, found the admin password, and used that to escalate their privileges. But we also, a lot of this problem stems from kind of assumptions-based approaches where, well, we'll set a best practices security policy and we should be good, right? But again, how are those being doled out? How are they being given? Do people really need all of those permissions? So a lot of this really comes down to gaining a good understanding about that and through monitoring. And we'll show you some good examples here on the next slide. All right. So we'll go ahead and press on here. So very difficult to do this manually, right? There's tens of thousands of permissions across multiple cloud service providers. AWS alone, roughly 8,000 permissions. Understanding the authorization model, it's quite complex. And quite frankly, within AWS, there are aspects of that are literally changing daily. So there is an approach of basic visibility, but then you start to dive deeper into understanding, how these things are collaborating, what types of things are people accessing, how are they using them, where is my low-hanging fruit in terms of high-risk items. And in addition, all of that accounting, auditing, and attribution is quite a daunting task. We also work frequently with a lot of customers that are coming up for their annual audit, and trying to figure out where to start with that is a Herculean effort. For example, one large power company we work with takes them 6 months to prepare for their annual audit, right? So there's a lot of automation you can leverage to greatly minimize the effort involved in having to understand where those risks exist in the environment. We'll focus on, of course, on AWS. Sources of forensic data include CloudTrail, Access Analyzer, Access Advisor, and CloudWatch. There are other things as well. For those of you who are supporting hybrid cloud, I heard there might be a few. You can look at Microsoft Graph, Azure Graph, and this is also aggregated into Security Center, which is actually pretty good. And then also Google Cloud, has their logs too. And of course, there are a lot of different products out there. Some people are collecting their CloudTrail into things like Splunk, then trying to decipher a lot of this information. There are a lot of third-party apps you can plug into that to really bring that data to life in more of an actionable dashboard within Splunk. And the Splunk App Store, has a list of those apps sitting out there too. So, we've all logged into AWS, right? And as you start to look at things like the event history within CloudTrail, this can be kind of a daunting task. I logged in today to look at a variety of things. It took me forever to dig through many of these events. There are searches, there are filters, but again, it requires a knowledge of what exactly am I looking for and what is the nomenclature or the terminology I use in order to find those things. You can download these via CSV or JSON, and as I mentioned, people are consuming them into things like Splunk to do deeper and deeper searches into them. But if we download that JSON and we look at the formatting of these CloudTrail logs, what is the chemistry of these? How are these logs laid out? How do I make sense of them? And what's the most important data within them? In this case here, you'll see an access key ID actually being used. So that gives us some information that, okay, the authentication method here was not username and password credentials, but they are actually using AWS keys. Remember with AWS keys, at least by default, there is no multi-factor authentication. So in terms of, attackers, this is a much easier target, right? Normally to go after rather than, trying to log into the portal and exploit, accounts in that manner, whether they're doing brute force or things of that nature. But as we dig deeper into these logs, we can find an event name. This tells us a little bit about what is actually being performed. And in this case, we see list buckets listing, storage like S3 buckets, things like that. We see the source IP address that the person is coming from, and we get some unique information regarding their browser. So I'm able to kind of profile the individual, right? And this was a legitimate login, legitimate use of the infrastructure and the environment. But if I then compare and contrast this to another log entry, I find some anomalies. We've got the same access key ID here. But as we start to dig into it, the list buckets being performed, this is coming from a different IP address and a different browser. And so fundamentally, we can start to distinguish between, a lot of these activities that are occurring, both by IP address and also, if you have it mapped out or if you've got a third-party tool, by geo as well. But at the end of the day, you'll see that there's a variety of other things in here. You can see ARN, you can see username. So there's a lot of cool and interesting data in here that you can filter on and search against. One of the meetups that we frequently do is for different groups of that are part of the Cloud Security Alliance. And they kind of combined a bunch of research and authored an interesting blog. And AWS now provides some tooling to basically create a clean room. Been doing DFIR for many years, and in terms of forensics, it's that traditional approach of, hey, I've got a mobile phone, hey, I've got a hard drive, I'm going to bring this into a clean room, I need to make a copy of it or an image of it, so I'm not actually messing with the actual data, because whether it's a liturgical or non-liturgical investigation, I want to maintain the integrity of that thing, right? It could be a mobile device, it could be a hard drive, or in this case, the cloud. AWS does actually provide pre-provisioning tooling or the ability to set up this clean room. And so with a CloudFormation template, with snapshots, things like that, you can have this staged in advance in your environment. So that way now you have the ability to carry out your forensics in a safe an isolated environment, which may or may not need to hold up in court, right? But at the end of the day, put your best foot forward and try to maintain the integrity of what may have actually been breached. As I mentioned, a lot of details surrounding this are not only on the AWS website, but also with the Cloud Security Alliance. So here you've got kind of a mapping of this clean room and the steps involved in creating it, using it, and supporting it. You see a number of things here in terms of, verifying the instance, snapshot volumes, recording metadata. So there's a lot of cool and interesting things here that gets built out if you're using this CloudFormation template in creating the clean room, and then how you really use it in the event that there is some kind of breach in your environment and you need to do that incident response and forensics. There's some great resources out there on the web. Many of you, if you specialize in AWS, have probably heard of Scott Piper, and he's one of the leaders in terms of security when it comes to AWS. He runs his own conference similar to like a security B-Sides, where it's, FWD CloudSec. He normally runs that just before AWS reInvent every year. And this year they did it virtual, and a lot of those presentations are out there and available. But he has an awesome blog. He writes about all different aspects of security. He also posts multiple times a day on his Twitter handle as well, all different aspects of security, whether it be related to vulnerabilities, to updates and changes within AWS. If you're doing anything with AWS and security, he is definitely one of the top people that you probably want to follow. Rhino Security does a lot of reverse engineering research, and when it comes to a lot of the AWS breaches, they provide a really nice breakdown of those within a blog that you can read about, gain a better understanding around the tactics, techniques, and procedures, so that in terms of understanding, hey, this might be a new threat that's emerging. Hey, this is a new tactic that I've seen. This is a good resource for staying on top of those. We talked about the AWS readiness blog that I was speaking about earlier related to the Cloud Security Alliance. And this allows you the ability to download a how-to document. And also, I believe there's a hyperlink to AWS. And both of those sites really provide a lot of good information about leveraging that CloudFormation template and setting up that clean room within your cloud infrastructure within AWS to be prepared for a potential, incident response and forensics that you may need to perform. And then SANS is starting to publish some really good white papers. I've been involved with them on and off for many years. They have some new white papers around doing forensics in the cloud too. A really good one that I just posted here in terms of a link is also a really good read as well, basically performing forensics within AWS. At AWS reInvent last year, the AWS CISO had kind of outlined a strategy for 2020 for every security team managing and maintaining and ultimately protecting AWS for their respective companies. The first few are quite obvious here, right? Encrypt everywhere and embed security in development. But what we've learned still from many of the recent breaches is there's not a good enough understanding of knowing who's doing what, where, and when, right? And gaining those deeper insights. So hopefully in what we've covered today in just a short 45-minute presentation, of which could probably be extended into a week of hands-on labs, right, is to understand, gain an initial understanding of where do I start? What are some good resources? What are a couple really top risky permissions that I should focus on or look for, right? As I start to build out how we're going to approach this. And as we mentioned, a lot of that really comes down to the granular permissions. I'm still learning every day by doing my own labs and training to gain more and more understanding around this. I learn a lot by going to Scott Piper's site, right? And reading through those blogs and testing things out for myself. And then leverage automation as much as you can, because it's really hard to do this manually. And I'll leave you with a lasting thought before we open it up for Q&A. And this comes from a letter to a senator that Stephen Schmidt, the CISO for AWS, had outlined. And this was following one of those prominent breaches. And he said, even if a customer misconfigures a resource, if the customer properly implements a least privilege policy, there is relatively little an actor has access to once they are authenticated, significantly diminishing the customer's risk, or what many people like to call the blast radius. It can be difficult to do that in your environment, right? Least privilege sounds great on the surface. And then as you start to figure out, how do I figure out what permissions people are using? There are methods by which you can calculate that. But then once you've removed access, how do you provide it back? Are you causing, more problems by removing that access? Not necessarily. In today's world, right, there's also that just-in-time or privilege-on-demand access. And so more and more organizations are leveraging that by both, find a balance between the two where they can set least privileges, and then as Dave, the developer, needs access, allocate that, have that go through admin approvals, and really operationalize how you handle getting out all of these permissions. And at the end of the day, getting ahead of a potential breach or exposing yourself to some of these risks in the first place, rather than postmortem. So thank you so much for your time today. I hope you got a few gold nuggets out of it. Like I said, we could spend a week talking about this 8 hours a day for 5 days and hands-on labs, but hopefully we've scratched the surface, given you a few cool and interesting things to walk away with and think more about, and also some resources you can go to delve deeper into all of this. I will provide a copy of these slides to Patrick to distribute the team, or if you decide you want to reach out, I'm happy to provide them. My email address is listed there on the screen. And then I'm fairly active on Twitter as well. But thanks so much for having me. Hope you got some good info out of it. Thank you.
Great. Thank you so much, Mike. And thank you to both the CloudKnox and the GuidePoint teams for helping put on today's event. And again, please definitely engage with us after the event, either through our meetup sites. We also have a public Slack team set up you can access from Meetup as well. And as Mike said, we'll get the video and the slides posted to the Meetup site within the next few days. Thanks again, everyone, and have a great night.
Thanks, everyone. Great job, Mike.
Thanks, everyone. Have a great night. Bye.